Florida Part 2, the formation of the Florida Everglades and the Florida Keys and current Florida environmental issues. I'm Helena Aves, a geologist and historian. Part 2 of this presentation will discuss the Florida Everglades and the Florida Keys. They were formed through unique geological processes over millions of years. The Everglades developed as a vast wetland, while the Keys originated from ancient coral reefs. Today, these areas face environmental challenges like wastewater management and mining pollution, as well as urban development, making conservation efforts crucial to their preservation. Here's a picture of the massive Florida Everglades. The Florida Everglades are an expanse of freshwater marshes, mangrove swamps, forests, and coastal marshes. Over the last 100,000 years, the Earth has experienced several glacial and interglacial periods, which are part of the larger Quaternary glaciation spanning from about 2.6 million years ago to the present day. Interglacial periods are warmer phases between glacial periods when ice sheets retreat and sea levels rise. The Earth is currently in an interglacial period known as the Holocene, which began around 11,700 years ago and continues to the present day. During interglacial periods, temperatures are warmer and ice sheets are smaller or absent. Glacial periods, also known as ice ages, are times when large parts of the Earth's surface are covered by ice sheets and glaciers. These periods are characterized by colder temperatures and lower sea levels. The most recent glacial period occurred between 120,000 and 11,500 years ago. During this time, ice sheets covered large parts of North America, Europe, and Asia. The last glacial period, also known as the last glacial maximum, occurred approximately between 115,000 and 11,700 years ago, with the most recent glacial advance happening around 26,500 years ago. This period marked the end of the last ice age and the beginning of the current interglacial period. Let's talk about the creation of the Florida Keys next. The most recent limestone formation of the Florida Keys occurred about 120,000 years ago during a warmer phase of the current ice age. The Florida Keys were formed in the last interglacial period when the sea level stand was higher and the climate was warmer. The Key Largo limestone and Miami limestone was formed about 120,000 years ago. As the diagram indicates, the Key Largo limestone was formed about 125,000 years ago. This was a period of another interglacial warmer period between two ice ages. And it was warmer than today, and the sea level was considerably higher, and the coral reefs were beginning to build on the top of the older Florida Keys. The Key Largo limestone, also known as keystone, which is a very popular building facade material in Florida, and it's shown here being mined at the Isla Morada quarry. This is a photo of a brain coral, part of the reef, Key Largo limestone reef, which is being mined at the Isla Morada quarry. Here are some examples of the keystone building facade that is used in Florida. The Coral Gables Museum is a good example, and so is the David Dyer Federal Building in the United States Courthouse in Miami. The creation of the current Florida Reef Tract. The Florida Reef Tract, also known as the Great Florida Reef, is the only living coral barrier reef in the continental United States. It lies a few miles seaward of the Florida Keys and extends about 270 kilometers, 168 miles, from Foy Rocks just east of Soldier Key to just south of the Marquesas Keys. The most recent reefal development, the one we currently know, is the Florida Reef Tract. It started growing about 15,000 years ago as the sea level again rose after the last glacial period. This reef is the only living coral barrier reef in the continental United States, and the third largest coral barrier reef in the world after the Great Barrier Reef in Australia and the Belize Barrier Reef. Lastly, let's touch on some current Florida environmental issues. This slide shows the phosphate deposits in Florida. They are spread from north to the central portion of Florida. The largest deposits are those found in the midwestern portion of the state, in particular around the Tampa Bay, Gasparilla Sound, and Charlotte Harbor area. Florida phosphate deposits are very significant. Florida produces about 30% of the world's phosphate at this moment. Phosphate rocks contain both calcium and large quantities of phosphorus in a mineral apatite. One of the reasons why these phosphate deposits in Florida are environmentally problematic is because they are strip mined. Pure phosphorus is used as an ingredient to make other chemicals. The most important use of phosphate rock is in the production of phosphate fertilizers for agriculture. How did the phosphate deposits in Florida actually form? The phosphate deposits were created in Florida and in some portions of North Carolina as well when the carbonate platform was submerged and there was an upwelling of deep nutrient-rich waters which created these phosphate deposits. The top diagram will show you how these currents and their movements occurred. The bottom diagram shows you in cross-section the upwelling of the deep nutrient-rich waters that were coming from deeper on the slope areas and being deposited on the carbonate platform. What are environmental issues that need to be addressed? After being mined for phosphate, these refuse, or known as tailing piles in the industry, are stacked up to 200 feet tall into what is known as phosphogypsum stacks. And here's an example of one near the port of Tampa. You can see that it is considerably tall. And the other aspect, which we'll get into in a minute, is the fact that these things leak and they get into the aquifer system. Phosphogypsum is a byproduct of the production of fertilizer from the phosphate rock. Phosphogypsum is usually not used and it's a waste product, but it is stored indefinitely in these stacks. The long-range storage of these phosphogypsum stacks is very controversial, in part due to its weak radioactivity. In addition to that, the sinkholes are created at the site and can contaminate the aquifer at that location. These are very large structures. All in all, there are considerable problems. The concerns of acidic mining, water drainage, the release of potentially toxic metals, the release of radioactive elements, and the phosphates and the nutrients in the runoff, which can cause mass kills in the oceans. Another environmental concern is the issue of Florida sewage disposal. In particular, let's look at the Miami-Dade County area, which has a very large population. Historically, it has disposed of its sewage through the ocean outfall pipes, indicated on the diagram and accentuated with an arrow, a red arrow. The pipes directly send the sewage along the Florida current and into the Gulf Stream. These considerable issues created environmental concerns, which spurred lawmakers into action in 2008, and the state enacted a law to end regular use of pipes by 2025. The county is building injection wells designed to pump treated waste in the cavernous deep wells in the boulder zone at about 3,000 feet. The pilot hole shown on the diagram went down as deep as 10,000 feet. The cross-section shown indicates the various aquifers in the southern Florida area, and in particular, the cavernous boulder zone at approximately 3,000 feet. It is believed that the salinity of the boulder zone is similar to the ocean water and thought to be connected to the Atlantic Ocean and thus dispersed over millennia. I'm including some references that were utilized for this presentation. In particular, I want to point out the work of Albert C. Hine of the College of Marine Science and the University of South Florida. As I mentioned initially, the geological history and the outcrops of Florida appear to be, on first inspection, rather simplistic. However, after digging into the geological history a bit further, one can really see that it is an interesting but complex geological history. I hope you enjoyed this presentation.